Okay, we are going to learn Charles' law. Good afternoon. Good afternoon. We are going to learn Charles' law. Charles' law. What is Charles' law states? States that in a fixed mass of gas, states that in a fixed mass of gas, volume is directly proportional to the absolute temperature provided pressure is kept constant. Okay, so Charles' law states that in a fixed mass of gas, volume is directly proportional. Volume is directly proportional to the absolute temperature provided pressure is kept constant. So that is Charles' law. Okay, again I repeat to you, Charles' law, volume is directly proportional with temperature. The volume is directly proportional with temperature. Volume is directly proportional with temperature. Okay, volume increases when temperature increases, the volume increases. When temperature decreases, when the volume also decreases. So this is called temperature versus volume. Provided pressure must be kept constant. In the scenario, two scenarios. For example, first of all, we have two scenarios. First container with the gas, the volume, gas, and temperature. The same gas and volume increases when temperature increases. Same container, same gas, but pressure in the both situation, same container, the pressure is kept constant. Pressure must be same. Pressure is not changing. Pressure is kept constant. So volume is directly proportional with the temperature. The formula for this one, V1 over T1 equals to V2 over T2. V1 over T1 equals to V2 over T2. This is Charles' law formula. This Charles' law formula is a relationship between volume and temperature. And this is the formula V1 and T1, V2 and T2. Volume, V is volume and T is the temperature. But very, very important factor. Under Charles' law and pressure law, same thing, pressure law. I'll teach you a pressure law next class. But Charles' law and pressure law, there's one important thing. Very, very important. The temperature should be in Kelvin. Temperature must be in Kelvin. Temperature is not in Kelvin. Normally temperature is Celsius. But temperature must change. If you want to use the formula to calculation purpose, temperature must be in Kelvin. Okay, I will teach you how to change temperature in Celsius to Kelvin and Kelvin to Celsius, vice versa. Okay. So first of all, Charles' law, volume directly proportional with temperature. Absolute temperature measured in Kelvin. Temperature, but pressure is kept constant. So there's volume and temperature. Volume and temperature. Okay, and the temperature must be in Kelvin. I tell you again, in the question they give temperature in Celsius. You have to change Celsius into Kelvin. You have to change Celsius into Kelvin. So I will teach you now how to change Celsius into Kelvin, Kelvin to Celsius, vice versa. Okay, and okay. Now the degree Celsius to Kelvin. Degree Celsius to Kelvin. Okay, degree Celsius to Kelvin. Okay, 0 degree Celsius equals to 273 Kelvin. 273 Kelvin. 1 degree Celsius, increase by 1 degree Celsius, you must 1 plus 273. So equals to 274 Kelvin. If 2 degrees Celsius increase, 2 plus 273 equals to 275 Kelvin. Okay, 10 degrees Celsius, if we increase 10 degrees Celsius, is 10 plus 273 equals to 283 Kelvin. 283 Kelvin. Okay, so Celsius to Kelvin, you must add 273. You must add 273. Okay, you must add 273. That's called Celsius to Kelvin. Okay, Kelvin change to degree Celsius. Kelvin change to degree Celsius. Okay, Kelvin change to degree Celsius for 300 Kelvin. For example, 300 Kelvin. 300 minus 270. That's equals to 27 degrees Celsius. That's equals to 27 degrees Celsius. Okay. For example, under 50 Kelvin. Example I'm giving you. Under 50 Kelvin, change to Celsius. Kelvin change Celsius. Under 50 minus 273. Minus 273. So that is equals to negative 123. Negative 123 degrees Celsius. Negative 123 degrees Celsius. And 4 Kelvin, this is 4 Kelvin. 4 Kelvin equals to 4 minus 270 equals to negative 269 degrees Celsius. 0 Kelvin is not okay, no? 0 Kelvin. 0 Kelvin change to Celsius. 0 minus 273 equals to negative negative 273 Celsius. So I repeat once again. Degree Celsius to Kelvin, you must plus 273. 0 degrees Celsius equals to 273 Kelvin. 1 degree Celsius, 1 plus 273, 274 Kelvin. For example, 2 degrees Celsius, 2 plus 273, 275 Kelvin. For example, 10 degrees Celsius means 10 plus 273, 283 Kelvin. That is called degree Celsius, how to change Kelvin. Okay, now Kelvin change to temperature Kelvin change to Celsius. For example, 300 Kelvin change to Celsius means 300 minus 273. Minus 273, that is called 27 degrees Celsius. Under 50 Kelvin, for example, under 50 Kelvin equals to under 50 minus 273. Under 50 minus 273 equals to negative 123 degrees Celsius. 4 Kelvin, 4 minus 273 is 269, negative 269 degrees Celsius. 0 Kelvin equals to 0 minus 273 equals to negative 273 degrees Celsius. So, you must understand degrees Celsius to Kelvin. Kelvin change to degrees Celsius. Celsius to Kelvin means add 273. You add 273. Kelvin to change to Celsius means minus 273 Kelvin. Minus 273 Kelvin. Okay, that is called, we call it, this is called vice versa. Celsius, Kelvin, Kelvin, Celsius. Okay, I will give the graph now. I will give the graph about Charles' law. There are two graphs involving Charles' law. Two graphs. It's the same graph. As we learned Boyle's law, the four graphs. Same graph, but different. The volume is the pressure. The pressure is one volume. It's the same graph, pressure and volume, but a different way of pressure and volume is what we call diagnosis, or we call it pressure and volume is mentioned. Okay, but the four graphs. But same like this, Charles' law of two graphs. The first graph, volume and temperature in Kelvin. Temperature in Kelvin. The graph starts from origin. Okay, this point is the point origin is 0 Kelvin and 0 meter cube. Okay, 0 Kelvin, 0 meter cube. This point, x-axis, y-axis, 0 Kelvin and 0 Kelvin, 0 meter cube. What is the meaning of this one? 0 Kelvin, 0 meter cube. When the temperature achieves 0 Kelvin, 0 Kelvin equals to how many degrees Celsius? Just now we saw the changing. 0 Kelvin equals to negative 273 degrees. Negative, extremely cold. At negative 273 degrees Celsius or 0 Kelvin, the volume becomes zero. Volume becomes zero means what? What happened? For example, oxygen. We are breathing in, breathing out oxygen, breathing out carbon dioxide. So breathing in, breathe out. Breathe in air, breathe out air. So the air molecules are flying around. The volume, there's a volume. Air molecules, oxygen molecules, carbon dioxide is flying around. So there's a volume. But at 0 Kelvin, there's no volume. There's no volume of gas, oxygen, or carbon dioxide. There's no volume. There's no air molecules flying around. All the air molecules will lay down or on the floor. That is called. There's no volume. Very hard to achieve this scenario. I don't think so that anybody achieved this, but I don't know the latest discoveries. But I think what I heard that they never achieve 0 Kelvin or 0 meter cube. 0 meter cube. Volume is no. Volume is zero. Volume is zero when it's 0 Kelvin or negative 273 degrees Celsius. Volume is zero. Nobody achieved. Okay. This one 0 Kelvin equals to negative 270 degrees Celsius. At negative 273 degrees Celsius, volume becomes zero. Okay, and the temperature 0 Kelvin, and volume equals 0. This is the point. This is the original point. This is origin. Okay, temperature 0 Kelvin, volume is 0. It's very hard to achieve. So how? Extremely cold. For example, North Arctic and Atlantic and these poles. Temperature, the minimum temperature negative 50 something like that. Negative 50 or something like that. But negative 2 was extremely cold. Some more cooler than negative 50. Negative 50 also we cannot survive, Negative 273. At this temperature, the volume becomes zero. Okay. Another graph. Okay. Another graph. You can see the graph. Another graph, and volume is meter cube. The temperature in Celsius. Temperature in Celsius. Okay, temperature is Celsius. The graph start from here. Start from a y-intercept, x. Okay, this graph start from here. What is the meaning? Why this graph start from here? That one, temperature Celsius. Okay, what is the temperature of this one here? At this point, temperature 0 degrees Celsius. At 0 degrees Celsius, there is a volume. For example, the freezer. The freezer, you put what do you call it? Some chicken or mutton or something like that. You put freezer, and the temperature in the freezer at 0 degrees Celsius. Freezer. The freezer temperature is 0. Doesn't mean that there's no volume. Doesn't mean there's no volume. There's air. There's air. There's air inside the freezer 0 degrees Celsius. That means there's a volume. Volume is not 0. Volume 0 only at 0 Kelvin or negative 273. So the temperature here is 0 degrees Celsius. The temperature here 0 degrees Celsius. Okay, the temperature here 0 degrees Celsius. So at the 0 degrees Celsius temperature, and a certain volume, for example 20 meter cube, for example. So this is a temperature, this volume. So at this point, temperature 0 degrees Celsius. There's a difference, 0 Kelvin, 0 degrees Celsius. There's a difference. At temperature 0 degrees Celsius, there's a volume. For example, I give simply in a number. There's a volume, there's a y-intercept. There's a volume starting from here. Okay? This graph, we put unjurkan ke belakang lah. Okay. This extend at the back. At the back, this point is negative 273 degrees Celsius. This point and 0 meter. This point. At this point, negative 273 degrees Celsius, and the volume becomes 0. The x-intercept, y is 0. The y is represent volume, so volume is 0. So this point is the same point as this point. Same point. This point. Or we call negative 273 the temperature and the volume. Temperature and volume. So temperature is 0 Kelvin. 0 Kelvin, 0 meter cube. Negative 273 is equal to 0 Kelvin. At 0 Kelvin, the volume becomes 0. Can you understand, sir? The volume becomes 0. So this point is the same origin point of Charles law graph in Kelvin, temperature in Kelvin. Same graph, same this point and this point, same point. So there's a difference. This graph, temperature is measured in Kelvin. This graph, temperature measured in Celsius. But this graph is practical. In Earth, we are using this graph because temperature measured in Celsius. Because we are hard to get negative 273 or 0 Kelvin, where the volume is 0. So hard to get. So oxygen gas, carbon dioxide, nitrogen, all the gases, the measured temperature in Celsius. Or we change in Kelvin, can change in Kelvin, but measured temperature in Celsius. So the graph is starting from here, starting from the y-intercept. This is practical graph, the practical graph. That means the graph we can exist. The graph of gases exists. All the gases exist in this world. Oxygen gas, carbon dioxide, nitrogen, all the gases are subject or obey this graph. Because this graph shows There's a volume, there's a certain volume at 0 degrees Celsius. At certain volume at 0 degrees Celsius. So this graph starts from here. So this graph is practical graph lah. But this graph is an ideal gas graph. Ideal gas graph. Ideal gas graph. Ideal gas means the gas doesn't exist in this world. I don't know other world, but doesn't exist in this world. Doesn't exist in this world. So ideal gas is a gas. We call it the gas